So let's look deeper into the actual ports, those physical ports we were talking about. They are in charge of controlling wireless APs. Distribution system to the enterprise network. So this is what connects us to our enterprise network. It can even be directly connected to our APs, but in most cases, we use these ports to connect up to other switches, and then our traffic from our AP uses a CAPWAP tunnel to come back and communicate directly to our wireless LAN controller. We can assign multiple interfaces to a single port, right? Data must be tagged to support multiple VLANs on the same trunk. So whatever VLANs we're using, it has to be allowed on the trunk that we're using. So from our wireless LAN controller to whatever switch we're connected to, there has to be a trunk here. And this trunk, or multiple trunks, have to support the VLANs that are what? That are associated with our wireless environment. Whatever wireless LAN is tagged to whatever VLAN, that has to be supported. The basic service set ID in the encapsulated frame header identifies the wireless LAN of the AP. So an AP is associated with, in my case, let's say wireless LAN lab 1. That's the basic SSID, right? Well, that is encapsulated in the frame, and it identifies the wireless LAN and the AP. So this is going to be in there, and what else is going to be in there? AP whatever. I think closet was the one. This is then translated into VLAN tags on the distribution port. So look, let's slow this down. Let's take a moment to understand what's happening here. So communication between the AP and wireless LAN is encapsulated in a frame. The wireless LAN and the AP identifier are associated. This communication goes down and is translated into our interface. Our interface translates this into our VLAN tags. And that VLAN tag determines which physical port we're going to use. Remember, we have, let's say we have 4 physical ports. Depending on the VLAN we're using, let's say it comes in lab AP closet, that maps to, in my environment, VLAN 10. Okay, so VLAN 10, let's say port 1 is VLAN 20. Port 2, VLAN 30. Port 3 is VLAN 40. Port 4 is VLAN 10. So now I've delivered from my interface to the wireless LAN controller. This needs to go out VLAN 10. The wireless LAN controller, VLAN 10, that goes out port number 4. Delivery process complete. And same with the return. It comes in on VLAN 10. We get data coming in on VLAN 10. This is delivered up to the interface, which is delivered up to where? The wireless LAN or APs controlling it. And then whatever that is, if it's a broadcast, multicast, whatever, it goes out to those different APs. That's how our communication takes place. That's why we need the ports.